In this video, I'm going to demonstrate how to create a plot of the means with confidence intervals for data that correspond to a within subjects design, and in particular a factorial within subjects design with two independent variables. So I mentioned in a textbook that there's not really an easy way to do it or a very efficient way that involves just analyzing the raw data. You basically have to calculate the means and the confidence intervals and then place them into a data file, much like I have here, and then run a graph on top of those data. And so what I've done is I've created several columns of data, and the first one is point, that I've called point for point estimate. And these correspond to the means associated with each possible condition, which is measured on a 9-point scale with respect to student comfort. Now, where I got those means is that last table of means and standard errors and confidence intervals when you estimate the marginal means in SPSS. So here we've got 6.908, and that corresponds to this mean here, 6.908. And we got 4.418, and we have 4.418. And I've just inputted the other two means as well. Now the confidence interval, lower bound and upper bound, and that's what I've got LB and UB here, lower bound, upper bound, I got on this side of the table. 6.722 is where I got this value here, 6.722. And then upper bound, 7.094. 7.094. So each mean has its corresponding lower bound and upper bound 95% confidence interval. And so once you have these data points in SPSS, you then have to specify the levels associated with each independent variable so that it can identify which mean is what. So in this case here, I've got a plants within subjects factor, and I've coded 1 for yes, there's a plant in the office, and 2, there is no plant. And so this mean here, which is the highest numerical mean, there's a plant in the office, and it's also a tidy office. So cleanliness, 1 is tidy and 2 is untidy. And then I did that again here. This is tidy and this is untidy. So it's a little bit of work. It's a bit unfortunate, but this is one way to create some decent looking graphs to represent a within subjects design analysis factorial with the confidence intervals. If you don't want the confidence intervals, then you can just use the regular SPSS utility and then plot the means that way, as I did earlier in the chapter. So now that I've got all the data inputted into SPSS, it's actually quite easy to create the bar chart now. Click on Chart Builder, and you want a high-low chart, and push the high-low chart into the previewer, and you can see that it's asking for several variables. And we're going to have to also want a grouping variable because we're going to want to get columns of data because we have two independent variables here. So first, I'm going to put the point estimate in this closed variable box. And then I've got low variable, which is the lower bound, LB, and then upper bound goes into the high variable. Now, it's up to you how you actually specify which independent variable should go on the x-axis and which should go on the panel, but there are times where it actually tells a better story one way or the other. And in my opinion, this time, it's best to put plants on the x-axis. So whether there are plants in the office or not, and put cleanliness as the panel variable, which is going to split the chart in two. So let's actually click OK, and here we have the results, and we can see that the point estimates are the circles, and the upper bound and lower bound are the whiskers, if you will. And so this looks similar to the chart I presented in the textbook, but I did make some changes. So first I want to double click on the chart so that I can get the chart editor up and get rid of the gray background. So that's the fill, get rid of the fill, and get rid of the border. Apply. And you also probably want to get rid of this plants categorical labeling. I would actually just click twice slowly on each label and write something like plants and no plants. Something nice and simple and easy, but also sufficiently informative to tell your reader which condition is which. And then I change the font and the bold, and then I can get rid of this and apply. Oop, there we go. I want to change my number format. I just want 1 decimal place there. Now the default in SPSS was to do something from 0 to 8 in terms of the y-axis, You might want to change that. Arguably, it's 1 to 9 because that's actually how it was measured on a scale of 1 to 9. Now, arguably, that's how you should present your results in a way that's not misleading, but we can exaggerate the magnitude of the difference by changing the scale to something like 3.5 to 7.5 and having major increments of 1. And now we really can see clearly how much of a difference there is. Now, I presented the results this way in the textbook because I really wanted to show the difference between the confidence intervals estimated in the unadjusted way, which is how I presented them here. And then later in the textbook, in the advanced topics, I demonstrate how to calculate the adjusted confidence intervals for this analysis, which is arguably more accurate in the context of a within subjects ANOVA. So let me just change this last thing here. We've got, get rid of all that and change that to comfort. Something like that. Now, there are no necessary ways to do any of this. I've just shown you the way I think is good. I also changed the level of thickness of these elements to 1.5 because I didn't think it was sufficiently clear. And I could change the capital on this. I could even potentially get rid of this title here, but I think it's not too bad having a title like that. And then you can change the actual size of the whole chart to something like this. And then we've got something that's actually, this is probably publication ready. This is the interaction effect associated with the study relevant to a professor having a plant in the office versus whether the office was tidy. And again, the interaction is observable when you consider the impact of having a plant on a tidy office versus no plant. Really quite a big difference here relative to the difference in the untidy office. So yeah, adding a plant to an untidy office seems to make a difference, but it doesn't make nearly as much of a difference in comparison to when you have a tidy office. And you can also see clearly the main effect of tidy versus untidy here. There's clearly a difference between both of these means and both of these means. But usually the reason you would present this type of chart is to help describe the nature of the interaction.